Okay, so here are two more example problems of determining the types of forces and then putting them in order for melting point, boiling point, sublimation point, freezing point, depending on what type of phase change we're looking at. So this is practice exercise 2, and we're given 3 molecules right here. And we're asked, first of all, what types of forces are in between these molecules, what intermolecular forces are there, and then to list them in increasing boiling point. So let's break apart each one of them, and you might have to draw some of the Lewis dot structure for each one. So this is a CH3, and then it's connected to a CH3. And once you've drawn the Lewis dot structure, you can tell that this is perfectly symmetrical, and so it's a nonpolar molecule. Since it's a nonpolar molecule, the only kind of force that's going to act between this and another CH3 is a London dispersion force, or a dispersion force, because that's in all things and happens only with instantaneous dipoles. So LDFs are the only kind right there. This one right here is CH3OH. If you draw the Lewis electron dot structure for this one, you'd see that we have an asymmetrical molecule, and then we have an OH sticking off this end. And so a hydrogen connected to an FO or N, not only is this molecule polar, but it has a special type of polarity where we have an H connected to an FO or N in a molecule, giving rise to hydrogen bonding. So this one has London dispersion forces like everything else, but then it also has hydrogen bonds. And hydrogen bonds, as we know, are very, very powerful. And then the last one right here looks just like this one, except this one's got CH3, CH2, and then this OH sticking off the end right here. And so it's the same as this guy, where we've got hydrogen bonding forces in it, but we've got a few more electrons in here too. So it's London dispersion forces a little bit more than these guys, because we got a few more electrons from these extra atoms, and then we also have hydrogen bonds as well. So those are the types of forces that are inside of each one. Now let's list them in increasing boiling point. Well, our one that would boil the lowest, or change from liquid to gas the lowest temperature, would be the CH3, because it only has London dispersion forces. And remember, those by themselves are medium strong, but not super good. But if you add in the hydrogen bonding forces, of course, it's going to be a lot stronger. So our next one then would be this CH3OH, and our last one would be the CH3CH2OH. The reason being is they both have hydrogen bonding, but this one's got just a little bit few more electrons in it, which would give it a few more dispersion forces. And so although the hydrogen bonding would be equal in each one, we'd have a little more London dispersion forces in this one, giving it a little bit higher boiling point. All right, last one right here. List these in increasing melting point. So to do this, once again, we need to say what types of forces there are, and then we'll list them in order of increasing melting point. So argon, well, that's just an atom, right? And it's only got like 20 electrons or so. And so the only thing inside of this one would be London dispersion forces. No polarity there, no positives and negatives. Chlorine, well, same thing. I mean, it's only 2 atoms stuck together. It's a little bit bigger than argon, because obviously chlorine's a little further down on the periodic table. And there's 2 of them, of course. So we got a little more surface area here, but we only have London dispersion forces. But it would be a little bit higher than argon. CH4, if we put that guy together, well, this one is perfectly symmetrical, and it has less electrons probably than argon even, because it only has carbon's electrons and then 1 from each hydrogen right here. So only London dispersion forces and even less electrons than argon does. CH3COOH, oh my gosh, that's a huge molecule, right? And then we've got this C double bond OOH like this. We've got hydrogen bonding in this one, and we've got a big molecule right here. So we got LDFs, we got H bonds. Okay, I already know which one's going to be the highest boiling point, and that's this guy right here, the biggest. So let's put him way over here at this side, CH3COOH. Okay, highest boiling point. Next one would probably be our one, since they're all the LDFs, the one with the most electrons, and that would be our ClCl. And then our next lowest one would be the one with the next most amount of electrons, which would be argon. And then our one that would have the lowest melting point would be our CH4, because it has the least electrons. And if you look up the data online, you find out that CH4 has a melting point of approximately 182, argon about 189, Cl2 negative 101, and CH3COOH about 16. And so you can see that these two are just like super close to each other. They both don't stick together very good, and would be like, it'd be hard to tell which one would actually stick together better. And so even though you know the intermolecular forces, you know there still might be a few degree difference between the two, maybe because of a little more surface area here, maybe because of a little bit smaller here, but that would be a tough one to tell on like a test question. You probably wouldn't get something like that. But these you should be able to tell for sure. You know, pick any one of these and those two as well, and it shouldn't be too difficult. All right, that's an overview of the types of forces, boiling point, melting point, changes in state, and how it's affected by those forces.